What up, people? I made you this lesson because I couldn't be at school today, and this is what we would have done. So I want you to watch this and copy it on your paper, and hopefully it makes sense, but if not, just ask me for a prize. Okay, so today we're doing some review of inequalities, and um, you're going to be asked to graph systems of inequalities. So we're just going to start with the basics of solving inequalities. So you might have seen this before. We'll start with this first question right here. I'm going to rewrite it as 9 is less than n over 10 plus 8. We're going to solve this as though it's an equal sign. So I'm just going to ignore the fact that it's a less than. I'm just going to use uh, an equal sign there. Okay. And then I'm going to solve as usual. So I'm going to subtract 8 from both sides. So I have 1 equals n over 10. And then I'm going to multiply both sides by 10. And then I have 10 equals n. Okay, so that tells me where I'm going to put my point on the graph. So I'm going to put a point on the and there's a question about whether we make an open dot or a closed dot when it comes to inequalities. So since this was just a less than symbol, I'm going to use an open dot. All right. If it had been, and maybe you want to write this on your page somewhere, a greater than or equal to, or less than or equal to, or greater than or equal to, we're going to use a closed dot because that means that the value is included. If it's just one like this without the little line, that means it's just greater than or less than. And then we're going to use an open dot. Okay, so open dot. And then the question is, where do we shade? Because it's not just unequals, it is actually an inequalities. So what we do is we take our value of 10, actually we take a test value, and we're going to sub it back into the original equation. So I'm gonna notice that this number line keeps going here. There's a 1 and then there's a 0. I like using 0 as a test point because it's an awesome number that makes fractions go away and just makes everything a lot easier. Okay, so I'm going to test 0. So I have 9 is less than, and instead of this n, I'm going to put 0 over 10 plus 8, and I'm just going to work out and see if this inequality is true. So 0 divided by 10 is 0, plus 8 is 8. Now the question is 8 greater than 9? Remember, 8's the bigger thing. And the answer is no, it is not. That means I'm not going to be shading over the 0. I'm going to shade in the other direction. Here we go. Okay, now let's move on. And by the way, if you need to see that again, pause it, watch it again. Okay, so now we're going to graph lines that are inequalities. So basically what we do is we draw the line like normal, and right here it has all the rules. So if you have this or equal to, you're going to need a solid line, or if you just have the less than or the greater than, you need a dotted line. Same idea as we talked about with closed dot and open dot. And then you're going to use a test point to shade. So my example here is the equation y is greater than 1 half x plus 3. So my y-intercept is the 3. So that's where we start at this point on 3. And then my slope is right here. So I'm going to go up 1 over 2, up 1 over 2. And then because it's just a greater than symbol, I'm going to use a dotted line instead of a solid line. There we go. Now we're going to figure out where to shade. So I like using the test point 0, 0 because, like I said before, 0 is like such an easy number. So here's the subbing in. So we sub 0 back into the equation for x and y. So 0 is greater than 0.5 times 0 plus 3. Now 0.5 times 0 just makes 0. So that kind of goes away. So we have 0 is greater than 3, which is false. So we're not going to shade over 3, over 0, 0, sorry. Now notice that any other point in the shaded region is going to work in the inequality. Let me just pick one to show you. So let's say if I picked this point right here. This point is -4, 4. Okay? I'm going to test -4, 4. Just to show you what I mean. So in my original equation, I'm going to put a 4 for y. I have 1/2, and then -4 for x, and then plus 3. So 4 is greater than. Now this part with the fraction could be tricky, but remember it's over 1. 1 times -4 on top, 2 times 1 on the bottom, plus 3. -4 divided by 2 is just -2. -2 plus 3 is 1. And the question is this inequality true? Is 4 greater than 1? Yes, it is. And so that's why it's included as a solution in this inequality. So every single point in this shaded area could be subbed into the original inequality, and the inequality would be true. Okay, so let's try another one here. Is that better or worse? Okay, let's try another one here. So I want you to give these two a try. Pause the video, try these two out, and then restart the video, and now I'm going to explain it. Okay, so pause. All right, so I'm going to graph this. This is a y-intercept of 3, and this negative for a slope, I always put that negative on top. You can pick top or bottom, it doesn't matter, you just can't do both, okay? So I'm going to put it on top, so that means I have -7 over 2, so I'm going to 1, 2, 3, 4, 5, 6, 7 over 2. Here's my second point. Now, because this is a less than, I'm going to do dotted again. I'm going to do a dotted line between those 2 points. And now I'm going to have to pick which side of the line to shade on. So I like to always use 0, 0 if I can. The only time we can't use 0, 0 is if the line goes right through 0, 0. I'm going to test 0, 0, okay? So 0 is less than -7 over 2 times 0 plus 3. So because we're multiplying this fraction by 0, it's going to go away. So I have 0 is less than 3. Is 0 less than 3? Yes, this is a true statement. And so we're going to shade all over on this side. Okay, hopefully you try the next one if you didn't pause it and then try it. Okay, so we're going to start with our y-intercept of -4. And then we're going to go up 4 and over 3. So 1, 2, 3, 4, 1, 2, 3. Here's our second point. This is going to be a solid line this time because it's a less than or equal to. So solid line. And then we're going to test a point. We're going to test 0, 0. Love testing 0, 0. So 0 is less than or equal to 4/3 times 0 minus 4. So 0 is less than or equal to. Now remember, this is going to go away because timesing by 0 makes it go away. Is 0 less than or equal to -4? Nope, not true. So we're not going to shade over 0, 0. We're going to shade on the other side. All right, there's our back. Okay, there's a back. This is the part where we get into more Algebra 2 territory. So now we're going to graph quadratic inequality. So that means you have to remember how to graph a parabola first of all. Now, if you get stuck graphing a parabola, you can always do a t-chart. But I'm going to remind you right here, if you remember how to do this, maybe you don't need this reminder right here. Okay, so here's my original inequality. I'm just going to treat it as an equals because we're going to do a test point to see where to shade. So I'm going to write my equation right here. Now, when my equation's in standard form like this, usually what we do is we factor define x-intercepts and then average them to get the vertex. So X-intercepts are found where y equals 0, so I'm going to replace y with 0. And I'm going to factor. Now, when I'm factoring, I always want to look for a common factor first. Now, all of these numbers are divisible by 2. And because it's an equation, I can just divide everything by 2. And on the left side, 0 divided by 2 is just still 0. 2x squared divided by 2 is now just x squared plus 12 over 2, 6x plus 8. Okay, now I'm going to factor. So I need factors of 8 that add up to 6. So those are going to be 4 and 2. And because this is a 1 in front of our x squared, we can use our easy factoring method. We do not need to draw our box. From here, I know my x-intercepts have to be -4 and -2 because of the zero product property, where we're asking what would x be to make this factor 0, what would x be to make this factor 0. Okay, then we're going to, so there they are on the graph, by the way, here. Then we're going to average these numbers to get our vertex. So we know our vertex should be somewhere at -3 because we can see that that's right in the middle of these 2 points. And so what I'm going to do is go back to the original equation, and I'm going to plug -3 for x. So I'm replacing x with -3, and I'm going to work with PEMDAS. So -3 squared is 9, 2 times 9 is 18, 12 times -3 is -36, 18 minus 36 is -18, plus 16 is -2. So here's our vertex is -3, -2. Okay, there it is right there. And so now you've got your parabola. Because of this lesson, we know it's dotted. So dotted parabola. And now we're going to use a test point to shade. So testing point 0, 0. You can see it worked out here. When you plug in a 0 to this inequality, you get 0 is less than 16, which is a true statement, which is why we shade all over underneath the parabola, because that's where the point 0, 0 would get shaded. Okay, so try the next 2 questions. Pause the video, try them out on your own. And hopefully you've done that. And now I'm going to go over them. So y equals 2x squared. Now I'm going a little bit quicker here because you can pause this and re-listen to what I'm saying. So x-intercepts first. Replace y with 0. Now again, I can see that I have a common factor here of 2. Divide everything by 2. So I have x squared for x and 3. Now, factors of 3 that add up to 4 are 1 and 3. And because I have a 1 in front of my x squared, I can do my easy factoring. And now I know my x-intercepts are -1 and -3. Okay, so right in the middle of -1 and -3 is -2. So that tells me that my vertex has an x of -2. But we still don't know why. So we're going to take that -2 and we're going to sub it back into our original equation. I am not going to sub it into the factored equation. I'm subbing it into the original. So -2 squared is +4 times 2 is 8. 8 times -2 is -16. So 8 minus 16 is -8, plus 6 is -2. So -2, -2 for our vertex. And it is less than or equal to, so solid parabola. And now I'm going to use my test point. I'm going to test 0, 0. So here we go. Test 0, 0. Okay, so 0 less than or equal to 2 times 0 squared plus 8 times 0 plus 6. So these two first terms are now 0. So the last one is 6. Is 0 less than or equal to 6? Yes, this is a true statement. So that means we're shading over 0, 0. So that means we're shading under the parabola. Okay, last one. Make sure you pause it if you haven't already given it a try. So our equation is actually in vertex form this time, which can be easier. So I'm going to remember that my vertex is the opposite of what's with x, so negative 1 and then positive 3. So negative 1 and 3. There's my vertex right there. Okay. Now, with vertex form, what I usually do is I'll make like a little t-chart to get two other points, one on each side. So negative 1, 3 being a middle point, 0 is 1 to the right, and negative 2 is to the left. So what happens when I sub 0 into my equation? So let's work on that for a minute. So y equals negative, you can't forget about that negative out in front, 0 plus 1 squared plus 3. So 0 plus 1 is 1 squared is 1 times negative 1. Now it's negative 1. So negative 1 plus 3 is 2. So where would that be? 0, 2. Now I already know that's going to be the next point because of symmetry, but I just want to show it to you. So I'm going to sub negative 2 plus 1. Now remember PEMDAS. Parentheses first. Negative 2 plus 1 is negative 1. Then exponent. Square it, it's positive 1. Now I multiply by the negative 1. Now it's negative 1. Plus 3 is 2 again. Now, because I have a greater than symbol, I'm going to go dotted. That. And I'm going to use 0, 0 for my test. Try that out there. So, remember, you have to test with inequality. Ugh, I don't have a lot of room here. So 0 is greater than negative 0 plus 1 all squared plus 3. So 0 plus 1 is 1. Squared is still 1. Now it's negative 1 plus 3 is 2. 0 greater than 2? The answer is oh. So I'm not going to shade under this parabola. I'm going to shade above. All right. So watch this video as many times as you need to. Hopefully that's helped you out. And I hope you have an awesome day.